Water. In the arid western United States, it seems there's almost never enough of it. But the biggest use of water in the West isn't for drinking. It's for growing food. Agriculture consumes about 90% of the water diverted by humans in western states. As the demand for water increases, the pressure's on to make sure every drop counts. It's tricky business gauging how much water farm fields are consuming, let alone how much water is seemingly evaporating into thin air. That's where water specialists Tony Morse, Rick Allen, and Bill Cramber come in. They're taking a long view of the problem, a very long view. They're studying farms from space.
The best general view. That is what remote sensing from space gives us. We get to see the relationships, the spatial relationships between elements that are too far apart for us to see them and understand them when we're walking around on the ground.
Landsat satellites take images in the visible spectrum, but they also capture images in wavelengths invisible to the naked eye. Landsat's thermal imager captures infrared data, which clues scientists in to how much water agricultural growers are using.
We can map where water is being applied and used, but we can also see how much water is being used, which is very important for applications here at Water Resources.
How can something like a thermal measurement tell us about water use? It's due to a familiar phenomenon, evaporation, or in this case, evapotranspiration. The term simply refers to evaporation of water from the soil, plus transpiration, the release of water through plants' leaves. As farmers irrigate crops, evapotranspiration causes the field to cool. The temperature difference is invisible to the eye, but is captured by Landsat's infrared measurements.
So by looking at cool areas and warm areas, in some ways that can tell us whether or not there's enough water to supply the needs of a plant, whether the plants are dry because of lack of water.
Several satellites have thermal imagers that can help measure evapotranspiration, but Landsat offers advantages. Landsat instruments capture a wide enough area to get the big picture, and the spatial resolution is high enough to not only make out individual irrigation projects, but to discern individual fields.
That is so powerful because we know that every field has its own behavior, its own characteristics, its own rate of development. We are now able to pinpoint water consumption on a field-by-field basis, which has never been possible before.
The information helps farmers and water managers target fields where water consumption might exceed water rights. Tony, Rick, and Bill's measurements have even been used to help settle water rights conflicts in court. For their innovative use of the Landsat data, the team was awarded a 2009 Harvard University Innovations in American Government Award. And they're depending on Landsat to deliver information as water becomes even more scarce.
Our water supply is going to come under increasing pressure from a changing climate and a growing population. We have to be able to measure water use in order to be able to manage it.
We are convinced that over the next 20 to 30 years, we will have millions of people in developing countries impacted with a more sustainable food supply brought by better management of water. And that water management is going to be propelled by the use of satellite technology.
As our planet changes, Landsat's over 25-year thermal record plays a crucial role in helping us understand how we've used water up until now, and how to make it last well into the future.